Hello, this is Mr. Stansbury. I'm going to take you through the notes on Venn diagram regions. At the end of this, you should be able to say, I can decipher information about different regions in a Venn diagram. Okay, so first off, there are four distinct regions on a Venn diagram which contains intersecting sets A and B. So this section here is everything that's in A, and it's also not in B. Okay, so this is A and this is B. Okay, this region here is everything that's in A and in B. This region here is everything that's not in A, but it is in B. And then this is everything that's not in A and it's also not in B. So those are the four distinct regions. Okay, now with that, let's do an example. Use the Venn diagram to find the number of elements in each of these. So it's not going to be finding all of the numbers, but just the number of elements. And so like in just P is 14, P and Q is 8, just Q is 21, and in neither is 5. Okay, so let's do this. Number of elements that are in P. So that would be everything in this region. So that is going to be 14 plus 8, which is going to give us 22 elements in P. All right. For Q, it's 8 and 21. So that would be 8 plus 21, which is going to give us 29. Okay. P prime, it's everything that's not in P. So here's P, it's everything else. That's the 21 and the 5, which gives us 26 elements. And then we have P intersect Q. So P intersect Q is this, but then it says, actually it says P intersect Q prime. So everything that's in P, right? So again, this might be a good spot to get some shading in here again. So let's do everything that's in P. And then it's not in Q. So everything that's, so here's Q. So it's everything outside of Q. So it's going to be all this stuff here. Okay, so where it intersects is just this one spot right there. So our answer for P intersect Q prime is just going to be those 14. Okay, P union Q, everything that's in P and also in Q. So that's the 14, the 8, and the 21. 14 plus 8 plus 21 is going to give us what? That's 22, 32, 42, 43. Right? Okay. P union Q prime. So it's P union Q are these, but P union Q prime is everything that's not in here. So that's going to be just those 5 that are left out. And then P intersect Q prime. So P intersect Q is just this here. So P intersect Q prime is everything outside of this region. So 14, 21, and 5. Okay, so that's going to be 21, 31, 35, 40. 40 total elements. Okay. All right, let's take a quick comedy break here, and then we'll get back to the rest of this.
Who's coming up with serving sizes? The serving size of ice cream is a half a cup. What is that? Is that like a joke some guy put on there? Hey, come here. Look what I put for the serving size. I just did it as a joke, but they're going out like that. I don't know what to do. Just let it go. I guess there's nothing you can do now. You ever know anybody to eat a half a cup of ice cream? Hey, you want to go grab something to eat? Oh, no. I had a half a cup of ice cream. Yeah, a whole half a cup. I just kept eating and eating and eating. I must have had 2 spoonfuls. I think a serving size of ice cream is when you hear the spoon hit the bottom of the container. Right? When you can't do this anymore. I even ripped the side. Not sure what they're talking about for that half a cup of ice cream.
Okay. Last example here. So example 8, given the number of elements in the universal set is 40. So we know that total in here we have 40 elements. The number in A in both of these regions here is 28. I'm just going to write it up here so that I don't have to go back and keep looking at it. The number in B, so both of these regions here, is 20. And then it says the number of elements not inside of A or not inside of B is 3. Everything that's not in A and not in B is this stuff out here. So they're basically trying to say that there's 3 that are not in either A or B. Okay? So now what we have to do is we have to figure out what goes in each one of these 3 regions. Okay? So what we, like a lot of people will look at this and say, wait, 20, 20, and 3, that's 51. But it says that there's only 40 total elements. You're right. Some of these 20 are going to be in here. Some of these 28 are also going to be in here. So we just have to figure out how many of these have overlap here. So we know we started with 40. There's 3 that are on the outside. So we know that these 3 areas here have to add up to 37. Right now, if we take all of A, 28, and all of B, 20, that tells us that those are 48 total elements. But we know there's only 37 spots, basically, right? So what we got to do is figure out what the difference is. So if we take 48 minus 37, that gives us 11. That means that there are 11, there's 11 elements that are in both of these. So we're going to put an 11 in here. And then now we can figure out what's just in A and what's just in B. So for just in A, we would do 28 minus 11, which is going to give us that there's 17 in here. For just B, that's going to be 20 minus 11. Oops. 20 minus 11, which is 9. So now we know how much is in each region. 17 plus 11 is 28. Plus 9 is 37. Plus 3 more is 40. And that's what we know we have to have in here. Okay? So that's the hard part. Now that we've done the hard part, now we can figure out the answers to these here. So the number in A union B. So that A union B is anything that's in A or anything that's in B. So that is going to be 17 plus 11 plus 9, which we figured out earlier was not 40, but 37. Okay. The number of items in A intersect B. So the A intersect B is just this middle region. So that's just 11. Okay. The number of elements that are in A but are also outside of B. So everything that's outside of B here. Okay, so let's maybe do the little shading trick on this one here too, just to help this make a little bit of sense. So everything that's in A, that's this here. And then everything that is not in B, so that's everything outside of this. So that's going to be all this stuff here. Right, all of that. So what do those have in common? It's just this one region right here with the 17 in it. So that's going to be, for C is going to be 17. Okay, and then the last one, the number in A prime intersect B. So it's basically kind of the opposite idea of that. So let's shade again. So everything that's not in A, so that is all of this stuff here. All of this is not in A. But then also everything that is in B. So we would have to shade everything that's in B. And what do those have in common? It's got that 9 right there in common. Okay? So that's all there is here for Venn diagram regions. If you have any further questions, please feel free to ask in class. Thanks.